Hello, hello. This is Postgres FM. My name is Nik, Postgres AI, and as usual, my co-host is Michael, PG Mustard. Hi, Michael.
Hello, Nick. How you doing?
I'm doing great. How are you?
I'm good, thank you.
I tried to say I thought, but actually, this is you who thought it's not enough episodes starting with multi-word.
Yeah.
So, what is the topic today? Tell us.
Yeah, this is I chose multi-column indexes, and I know we've talked about them a bunch. We've done episodes on things like index-only scans, for example. But it felt to me, looking back at those, that we didn't really get into some of the details around multi-column indexes that I find particularly interesting. I think also this is still the area I see people, especially fairly experienced full stack engineers, back end engineers, struggling with in terms of performance, or not realizing how big a difference they can make, or how helpful they can be in certain, especially a lot of the workloads I see are web application, just like a lot of reads, like maybe 80-90% reads, and a lot of trying to optimize performance of those reads, especially with the odd kind of aggregate type query. And index-only scans help a bunch, but only once you understand multi-column indexes. And I think there's some details in there that I'd like to discuss with you. So yeah, thought it was about time we actually had one dedicated to this.
Yeah, great. I guess we will be going slightly beyond just multi-column indexes, right?
Well, possibly, yeah. What do you mean?
Well, maybe the question is like how we can compare them, for example, having just indexes on single column, but many of them. And sometimes I have a case where people intentionally understanding consequences chose to cover every column with index, single column, I guess. And yeah, we usually say it's anti-pattern, right?
Well, I mean, yeah, I guess it depends. I've not seen a workload like with a set of access patterns where that would make the most sense. Personally, I tend to see tables that have some columns that get queried a lot more than others, and the groups of columns that get queried very often together. Lots of equality searches amongst, for example, account ID, user ID, but then maybe a range search in terms of date. And like that's the kind of query that ends up being like so much more efficient with a multi-column index than with a series of single column indexes. So yeah, the kind of access patterns I see, I can't imagine living without them. But I'm sure that, well, I'm looking forward to hearing about the case where it made most sense to.
Well, it was multi-tenant application where the freedom of queries is unpredictable. So every tenant can choose different types of filtering and ordering, and we don't know in advance. And they are not engineers, those tenants, right? So we need to give them some support, at least somehow. But index right amplification, I guess, is a killer in this use case if data size grows, right?
Yeah. And given it's a multi-tenant application, are we talking single database per?
Separate tables.
That makes way
Students
more
too.
sense.
Yes.
So that starts to make some sense. Then at least you're not.
Yeah, there are smaller
Yeah.
tables, of course. And there's isolation, complete isolation. So
Yeah.
all blocks and all tuples in these blocks, buffers or pages, how you name it, they are belonging only to specific tenants. So all problems only like they are localized. Yeah. Anyway, if we think columns A and B, and we have two indexes on both columns, when does it make to consider a two-column index instead? Right, this is a key question, I guess.
Yeah. I like that a lot. And I guess we probably should go one step back and say probably we're going to be talking about B tree indexes for most of this.
How about B3 indexes?
Yeah, well, there's a few the docs mention, and it's quite funny. The word "only" is still in there, I think, from the initial commit. So it says currently only the B tree, gist, gin, and Brin index types support multi-key column indexes, and that the key is the important word there. But basically, that means key columns not include columns. So there is a subtle difference there.
Well, gin indexes
But
cannot be multi-column?
Gin can, Brin can, Gist can, and B-tree can.
Yeah.
So when it says only, I think the only inbuilt index type that doesn't support multi-key
Hash?
column indexes is hash. Yeah, right. So
Yeah.
I think only is a bit of a dubious word there.
Is that it? Is that it? That's it?
I can't
Okay.
think of a sixth one,
Okay.
or maybe SP Gist, but like I think that's a subcategory of Gist. Anyway, basically, I think we're probably going to be talking about a B tree. Like the vast majority of indexes are a B tree, and the vast majority of multi-column indexes I see a B tree. Have you got any different examples other than maybe B tree gin?
Yeah, there's a problem with gin. I always like to talk about that if you have a scalar column of scalar values like timestamp or integer, big int, and you need to order by it and limit like 125,
Yeah,
then it can be inefficient because gin doesn't know. Like planner needs to choose to use only B3 or only gin. And this is where B3 gin can help to combine them into multi-column index, right? So
yeah,
we can talk about hybrid indexes when one layer is gin and another is B3, for example.
yeah. Well, and I think that kind of starts to get to why we need or want multi-column indexes in the first place, because I think a large part of it is ordering or clustering. Like you want it. B-tree is a simple example. Beautifully, it has a single order through the entire structure, right?
Single dimension.
Yes, exactly. So the order is really useful for things like enforcing unique constraints. Like things are placed in an order, and you can see, is there one of this already in place? And multi-column just gives you kind of order by the first of these columns first, and then for any that are equal, order by the second column next. And I don't think the docs make this super clear. I think they give a good example, but that could be clearer, I think, that it's single order and order by A, then order by B, and then C, and then D, and however many you list. And that's if they're key columns. Includes is a bit different. That doesn't affect the ordering, and that has some benefits. Well, we can discuss whether it does, I guess, in a bit. That's one of the main things I wanted to discuss with you, actually. I think that's a particularly interesting part. But that ordering thing is really, really important in terms of then choosing which order to index things in the first place. So
Yeah.
I've never come up with or come across a guideline that I'm totally happy with in terms of the
Well, it's straightforward. We discussed this 20 years ago in some circles. By the way, not only ordering but also filtering. If your filters involve range comparison or like between operator, right? Or in case of gist, it can be something else. Or so anyway, so it can be not only strict ordering but also just is it inside the range or no? Is it like more or less? These operators. But as for the rule, let me this time also step one step back and say,
yeah.
like, super roughly at high level, forgetting about parallel operations and so on, we have three types of access to data. Sequential scan on one side, for lots of data, it's the slowest.
Hmm.
Index and index only scan. Let's combine them in this case.
Yeah.
On another side, the fastest single index scan especially single index only scan is the fastest if you have a lot of data. And between them, there is a bitmap scan, which is a combination of a bitmap index scan, bitmap heap scan. And if you have, like, this is like proposal to have explanation why we need a multi-column index. In case of two columns and filtering or ordering on them, if you have two separate single column indexes, you likely will end up using either one of them or maybe both of them, but in the form of bitmap scan.
Yes.
which is not the most efficient. And with multi-column index can bring you the most efficient, either index scan or even index only scan, right?
Yeah, and
This
I
is
think there are exceptions or times where they're pretty much equal in efficiency,
of course,
but it's very, very easy to
yeah,
demonstrate with non-overlapping,
yeah,
like, data sets. Like, you quite often use the social media thing, right? If we had an index on user ID and a separate index on created at or, some kind of timestamp, looking at all of the users' posts in a certain time range, even if we can do the bitmap index scan on users just to find all of that user's posts, and then a bitmap index scan on all of the posts in that time range, it's very easy to see how we're having to scan a ton more data in that and then even though we're only looking at doing like the bitmap index scan, only having to look at the index entries, and the bitmap itself will be relatively small if that user doesn't have many posts, and then the eventual heap scan will be relatively small and relatively efficient. The actual initial scans to get the right data is huge compared to
yeah.
having a multi-column index with all of the users' posts next to each other with their created at timestamps. So it's, yeah, in terms of we often talk
We
about
could
buffer reads, right?
we could create statistics, right? And so the planner
Yeah.
would know that this user was recently active, so we need to follow the index on created at. And another user
Well,
is not recently active, so it's better to fetch all entries for this user and then order by in memory and have top end sort in memory.
but both it with any sufficiently active system, both would lose massively in terms of buffer reads still to the index only scan or even an index scan on a single multi-column index.
Yeah, yeah, yeah. Anyway, also what matters, random page cost matters here, right?
Yeah.
Because planner might, in reality, index scan might still be better or vice versa, but planner might think it can choose bitmap scan in favor of index scan because random page cost is 4, for example, default. Anyway, let's return
So
to.
while we're on the topic of outdated things, I actually think there's a relevant part of the docs that I have an issue with that I wanted your opinion on. It's in this area. It says multi-column indexes should be used sparingly. In most situations, an index on a single column is sufficient and saves space and time. Indexes with more than 3 columns are unlikely to be helpful unless the usage of the table is extremely stylized.
Hmm, I don't
Um,
remember these words from the docs. Interesting.
they're still there in the latest versions, and to be fair to them, they've existed since pretty much since 7.2.
I understand. In reality, it very depends on application. In some application, there are absolutely critical queries which must have index scan and sometimes even index only scan with aggressively tuned auto vacuum and visibility maps maintained very very well, so index only scan doesn't degrade. So I think this is like I can see why this was written, but I cannot agree with it in all cases because definitely we have 3-column indexes sometimes because we choose to have the most efficient path specifically to support specific queries which are most important for us. They receive a lot of traffic, so we cannot allow degradation here.
Yeah.
Right.
What about 4 or 5 columns? Well, I guess it's rarer. I don't see many, but I've seen a few.
Well, this let's a little bit postpone this
Yeah,
question
sure.
because I know you wanted also to touch covering indexes, right? Because maybe this is where we will discuss this. But let me return to your previous question:
Yeah,
how to choose the order. And I remember the rule originally was if it doesn't matter. So there are two rules, and you need to spend time understanding them. I'm pretty sure users, I mean, listeners who are most experienced, they know this very, very well. But I know a lot of unexperienced listeners our podcast receives. So two rules, one rule, and this is maybe most popular in terms of mentionings. The column on of the index on columns A, B makes a separate index on columns A, B, max index on column A, a single column index, like not needed. You can drop it, right? Because this two column index can support queries that need only index on column A, right? And this means that if you have queries dealing with both A and B in terms of ordering and filtering, and also you have queries that deal with only A, you should put A on the first place. This is rule number one. And there are nuances, of course. And
Yep.
second rule is if you cannot choose, if you have patterns that kind of imagine you have only one query which involve both columns. How to choose the order? And the rule says choose that column which will give you the highest selectivity and put it to the first place. So the scope of your scope narrows down faster. For example.
Yeah, I like it, and I think for single query, and I think there's another one I've heard is your equality conditions in the leftmost, and then if you have a range condition or an inequality condition, like a greater than or a less than, that needs to come last. So you got all of your equality conditions first, then a range condition like created at.
With previous one. Imagine if
Well, but it's really important for let's say you have a query that has like where A equals 1, B equals 2, C equals 3, and then D is between 17 and 1001. It's way more efficient to have the A, B, again, depending a little bit on selectivity. I'm sure you can come up with examples where it isn't true, but having A, B, and C in some order and then D last is really important to making sure that it's as like low buffers as possible in terms of that index scan.
But imagine we have a query, forgetting about order by and limit. We have a query which selects with two filters. One is some Boolean column and another is time range. So what should go first?
Well, so think about it though, because like, let's say they're 50-50. That's the simplest case, right? We've got 50% true, 50% false. Probably if we have a different thing, it's trickier.
It should be partial index actually, but yeah.
Maybe, depending if we need to like query the opposite one sometimes.
Maybe it should be two partial indexes.
Or I don't think so. I don't think two partial indexes are more efficient than.
But do you agree that filter on date usually, if for example we know that we usually select narrow ranges like day or maximum month, and we have a lot of data for many years, do you agree that the filter on timestamp gives you better selectivity in general case?
I think it has to, right?
Yeah.
What do you mean?
Well, of course, if Boolean column has it has two values, and most of columns have one value, but you're selecting another one, it's different story. Like deleted, where is deleted, and we know we have most rows not soft deleted, right, or something like this. In this case, the Boolean filter can give you better selectivity, but it's less.
So, but I think a scan. Let's think about like the buffer reads. If it's true and between these dates or between these timestamps, our index scan can be perfectly efficient if we index by Boolean first, then timestamp, because we only have to look at the true values between a certain date range. If we if we do date range, then Boolean values, we discard half the values we read. We read all of the date range and have to discard half the Boolean values.
Why should we read all the date, I don't get it. Why?
We should test it. We should. I reckon there'll be double the buffer reads.
I forgot to mention my main rule: always doubt and test in reality. Yeah.
Based on my understanding, that you'll get double the buffer reads for putting the date first and the Boolean second. So this is what I meant. All of the rules of thumb are good, but they're not perfect, and actually they're slightly contradictory. And I would say, like, even the most selective first think about the shared multi-tenancy thing.
Yeah.
I prefer account ID before user ID, even though user ID is definitely more selective. Partly because we're never really, well, in most cases,
Data
not.
locality, you mean, right? You need to
Data
take
locality is
into
one
account.
thing. Yeah, data locality is one thing, but also we're very rarely serving a single query with a single index. Normally, we're serving more than one in
Of course.
query, type. So, but then the rules start to not it starts to become a little bit more of an art form, and you're trying to think, what will they be in future? What's most likely? What might we want to query together? Like, it's quite likely we want to query users in the same account together at some point. Maybe we want to look at all posts by this account or this team,
Yeah.
and having that data closer together in the index has benefits than if we do it by user ID, and let's say well, no matter how you're doing user ID, whether it's um maybe they'll be clustered, teams. Like, maybe if you've got like a big int, maybe they'll be clustered close together, but they won't all be. You might add a team member many years after setting up your account, that kind of thing. So I prefer some breaking of those rules.
There is one more rule, which is
Go on.
foundational. We need data locality. By the way, I would like to think about it, and also partitioning if we have it. Of course,
Mm.
we don't want to scan all partitions, right? And actually, partitioning serves as type of kind of an index.
Kind of leading, partition
Yeah.
keys, kind of the leading column or leading columns
Yeah,
if you've got.
I
Yeah.
remember I was trying to create an index on partitioning key in each partition. It was so strange because this partition had only one value, and I was trying to include this as additional column, and somebody said we have partitioning. Why do you do this? So, and I realized, partitioning eliminates the need an additional step in indexes or some indexes. So what I was trying to say, additional rule is to remember the order of execution of select clause. Oh, not select clause, the whole query.
Yeah. Yeah.
So first, like we should think, for example, simple. Like let's keep it simple. Order by goes last, right? So if we have order by created at desk limit 25, it means created at should be the last step in the multi-column index, right?
Mm. Yeah, I never thought about it like that.
You
But yeah,
cannot.
that fits with the range thing I was talking about.
Yeah, but because order of execution, if you put created at on
Mm.
the first place, it won't be helpful.
Yeah.
It's a simple rule. Like it's intuition should tell you this, but maybe no. And yeah, but I agree with you that rules can be confusing a little bit, and it's better to test and learn, and sometimes doubt and test again. And testing, we should pay attention to buffers.
Yeah.
100%.
This is going to get better in Postgres 18, right? People are going
Yeah,
to get it by
can't wait.
default one. Yeah, me neither.
We already have customers migrating to 17. It's
Nice.
great. So next year, I expect buffers will become default, and I hope you will see a growing number of data with buffers. I mean, plans with buffers involved because it's
Yeah,
default. Yeah,
we definitely will.
cool. What about covering indexes?
Well, yeah, when I saw the commit for adding include to create index, so create index added this option to include certain columns in the leaf pages, so in the tuples that are stored in the leaf pages, so you can return more data. Like if a query, for example, wants your order by, like, maybe wants to filter by user ID equals this and name equals this, order by this date, the name could be a payload. It doesn't have to be in the index ordering, but it could be there in the index leaf pages.
To achieve
So
all scans. Right.
to achieve index only scans, yeah, very, very important. That's, I think, the only use case for this. But it's a very important one, important enough
The whole purpose
get
is
added.
to avoid
Yeah.
heap fetches, but that also works if under heavy load. It works only if you tuned to vacuum properly and avoid blockers of X-Min horizon.
Yes. Otherwise, your index only scans will end up just
Yeah,
as
they will
regular.
slowly degrade to index scans, basically.
Yeah. So yeah, but covering index, like the word covering for me, I think is slightly loaded because I think an index for me is covering for a query if you can serve it with an index only scan. In my opinion, we had covering indexes before this, before includes, because if you had a multi-column index on all of the columns that you
Yeah.
needed, that was a covering index for that query.
My favorite topic,
Name them.
criticizing the choice of
Yeah.
terminology in
Yeah.
Postgres. I agree with you. Yeah.
But I'm only reiterating this because I think it's important for people to understand. Like, I think it could be confusing if you hear that the covering indexes are only for the word when you use includes, because it's
Including.
confusing. So yeah, it got added in Postgres 11 2018, and I'm interested in kind of like the benefits over, like, why not just add it as another key? Like, what are the downsides to doing
I
that?
I spent some time thinking about it, and I
Mm,
came to conclusion when they were added in 2018. I spent some time, and yeah, and I came to conclusion that the key difference is the semantics of uniqueness semantics, right? So if you want, if you have like if you add additional column to your multi-column indexes, you change uniqueness semantics, right? If you
that's a
want
great point. Yeah.
if you want index only can work well, but you cannot. But this is unique index. This is where you should have including, but it's quite a rare case actually.
So let's say we want an index like on email. We could back to last week's episode or whenever it was. We want it to be unique on email, but we want to include the name as a payload. But we want to let people have the same name as each other, even if they.
Yeah.
But wait, because it's unique on email already, wouldn't it always be unique on email and name? Oh no, because then we could, if they had a different name, they could use the same email. Yeah, that's a problem.
So we don't want to have uniqueness on pairs of values. So for
Yeah.
example, if you want uniqueness only on email and name it
Yes.
something like it's just you said payload. This is good point of view on it. You're just
Yeah.
putting there as a passenger.
Yeah, that makes perfect sense.
Yeah, I also think. Do you remember? Is there any size difference? Or
Well, I was going to bring up the exact same thing. I wondered if it also got done for that reason a little bit, because if you've got the structure of a B tree, you've got once it gets sufficiently large, you've got levels of they kind of like look like an org tree, don't they? Like layers of management almost. And if you have a multi-column index with keys, so where they're part of the ordering, you need to preserve that information at the different levels, like for ordering purposes. But because includes columns aren't needed for ordering, they're not relevant, they only live in the leaf pages at the bottom level of the B tree. So size-wise, there should be a difference. But, and I think this has changed recently, deduplication, I think, changes this. Not for unique indexes, but in cases where you can have duplicates, which is quite a lot of indexes, I actually think the deduplication will normally beat the benefits of not having to store it storing the data at multiple levels. Obviously, depending a little bit on how big this data is. Like you're probably not putting huge payloads in this. But yeah, I think there was a size benefit. I think it's less now that we've got the B-tree deduplication work.
yeah, obviously, in the columns you include into including part of create index, you cannot use them in filtering and ordering. They are like passengers. They only beneficial for index only scans. But since they are sitting like basically in leaves, do you remember there is a problem with B3 on text. There is a limitation due to key size, right? So you cannot like 2000 something bytes or something like this. I guess in this case for columns used in including, there's no such limitation, right? I'm not 100%
There
sure.
must be a limit, right? Because it's still going in normal data pages.
I'm not sure. I'm not sure. Let's not jump to.
Wait, yeah, but I read this in the documentation and I haven't made note of it, but it is in the docs. I'll find it. And
But I must admit, this is a rare beast to meet in the wild. I don't see including the word often. I see, but not often at all.
Oh yeah, I was gonna ask. So generally you see people with
Yeah, yeah,
multi-column indexes, but they're all keys. Is that fair?
yeah. It's well, this is what Minds tells you. Including is still kind of exotic. It's good to have it, but not so obvious. Like when exactly you should use it. Well, we discussed it, but still, in normal practice, you say, I will just add it. If it's not unique index, why should I think about it? If
Yeah.
there are no limitations in key to be met, if it's just some timestamp or number, it's easier to add it, and that's it. So I wanted to touch one more topic here.
Yeah.
When we should avoid completely putting another column to multi-column index, or this type of indexes we just discussed, which are called covering, but you don't like it. When should we avoid adding such another column there? For example, we see, there is obvious benefit.
So when you say benefit, like benefit to a specific set of read queries, could be faster.
Imagine we have some simple case like a table, some filter with order by, and it's already working well, but we see like there is also column status. It has several values, and we see most of the time we select 70% of everything, like status equals active or something. But we think, actually, we could shave off. We see some rows are filtered out dynamically. This is what pgmaster always suggests immediately.
Yeah.
There is like index works inefficiently because later some rows you exclude, right? Rows filtered, or like how's it called? So
Well, yeah, there's a couple of ways that it can be either filter or an index recheck. Some types of index,
yeah,
and sometimes, like for example, with a bitmap scanner. I was looking at this today actually because Postgres 18 changes this a little bit.
yeah.
But exact heap blocks and lossy heap blocks, so that can end up with an
But I'm
index recheck.
but I'm talking about rows removed because we have additional part of the workload,
So a filter, yeah, filter.
and they are filtered out dynamically. And we think, it's not efficient. Let's go fully efficient. And we start adding, for example, status to like as additional column in our multi-column index, or it was a single column, but it becomes two column, right? Or we decide to use it as a condition and make index partial. So we say where status equals active because we know most of the time it's active, or something like this. Doesn't matter. So index starts using this column somehow, right?
Yep.
Any of three ways: another column, including, or where keywords. Is it a good
I know
idea?
what you're going to talk about. Are we going into hot update territory?
Exactly. So this is what happened to me. I was like enthusiastic optimizing some project. It was, I remember first time it was very long ago. It was DocSend. Later it was acquired by Dropbox. It was in San Francisco, and I was like, we optimized additionally, like shaved off like 20-30% of buffer hits and reads, and it's great. Like it's small optimization, but it's helpful, and we can pay this price. Okay, we need to maintain this index anyway. It's slightly bigger now, but it's still worth it. And then later I see degradation of updates. And you know why, right? Because we had hot updates. Because basically most of updates, they updated status.
Yeah.
Yeah,
Yeah.
and now it's participating in index definition. So hot updates, it makes hot updates not possible at all. And hot updates, just a reminder, we know there is new audience usually. So heap only tuple updates. This is update which changes only table pages of table data, and doesn't touch indexes. Because normally regular update, it needs to touch every single index, which produces more dirty pages, checkpointer or budget writer or even a big backend. They need to flush it to disk.
Mm-hmm.
It doesn't matter. And then it generates more wall, and it slows down updates. Like regular updates are much
Yep.
slower than hot updates. So just putting another column to your multi-column index might affect updates. This is worth remembering.
If it wasn't indexed already. Like, if it was
Yeah.
indexed
Fair,
already in
fair
some
enough.
other way.
Fair
Yeah,
enough.
yeah.
Yeah.
But it's a really good point, and I think those index efficiency tips are the ones, like, I think people are most surprised by. Like, people think they look through their query, they see, I'm talking about, like, experienced engineers, but not experienced Postgres folk. Look through a query plan, see index scan, index scan, index scan. Maybe there's a lot of loops. Maybe there is a rows removed by filter, but maybe it only says one, but it's like 20,000 loops, and they don't realize that that's the most inefficient part of their query. Like, just anyway. So I love those, but normally when it's like
Yeah.
index efficiency is, we talk about a percentage, like 0.1%, like that, or less than 0.1%. Great. If it's 70%, we score it much less well.
It's combination of factors, this choice.
Yeah.
But one particular case, which is very common, and when I see it, I immediately recognize the problem. If I see select blah 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 where some filters and then order by created at desk limit 100, definitely there are multiple indexes which include updated at, and there is a trigger which, or just some Ruby or Django, it doesn't matter, application which updates updated at always. So this table doesn't see hot updates 100%. And yeah, and how to break that issue, not losing the mechanics of updated at timestamp, I don't know. I try to sometimes to avoid indexing this. But
Mm.
if you present to your users values, really like you need a order by updated at desk limit something. You need it, right? I try to say, okay, updated at, it's very close to created at usually. Let's use created at, and then like somehow like it doesn't work well. So
It
yeah,
doesn't. I would have thought in most cases it would actually, but yeah.
depends, of course. It depends.
Yeah.
Sometimes it's good, like you basically already have almost everything and on the fly. Yeah, sometimes there is correlations, a very good correlation. But sometimes if it's on partition table, updates happening all the time, and
Mm.
it's a mess. And yeah, and updates might happen a month later, for example. This is like
Yeah.
screws this.
I will, for newer listeners, I'll link up our episodes on hot updates,
Yeah.
and we did one on limit that's really good for this.
Yeah. I just wanted to say this is a warning.
Yeah, yeah.
Yeah, multi-column indexes. Everyone needs them. I 100%. But we should be careful with if we need fast updates and fewer wall bytes put to wall. You know,
Yeah.
because wall bytes can be an issue, and they put pressure on both backups and replication systems. Right.
Yeah. Yes, and this is the old read versus write thing, isn't it? And also, like, if you've got a write heavy application, or if you're not doing many reads at all, you might not want many indexes at all. Like, it is a trade off in general, not just multi column, right?
Sometimes sometimes here it makes sense to split and have one-on-one relationship, two tables, and in one you update a lot, and
Yeah.
you give up, but you have only like 3 or 2 columns, and that's it, right? And another one has everything else and search and so on. But in this case, you will end up with the problem that we cannot create an index on two tables. We lose for some queries. We will lose in a single index scan. We will need to join. Yeah, so it's a
Back to
different.
denormalization topic again. Yeah.
Yeah.
I had one more on include. I wondered if it might end up with less bloat in some workloads. So when we're updating that column that's being included as a payload, for example, the tuple doesn't need to move in the index. So in the case where we've got them both as key columns, we're having to move the tuple to a different page, most likely, if it's like ordered by email then name, for example. If their name changes, probably the entry will move page, and you could end up with a split. So I was just thinking in terms of updates, I wonder if we'd end up with less index bloat if we used include instead of multiple keys. That it seems like a minor advantage, but I wondered if that could help as well.
Yeah, it's an interesting point. I should think about it.
Yeah. But yeah, it feels to me like Include feels like a scalpel, like a very specific tool that is
Including,
help.
it's, yeah, it's, the word is including.
Are you
It's,
sure?
no, I'm not sure. Include? Yeah, it's includes. I don't know, it was a bug in my mind. Sorry. Yeah, include.
It's not even includes plural, it's includes singular.
Yes.
Yeah.
Yeah,
But that shows how common, shows how commonly you see it.
it's
Yeah.
rare, super rare.
Including would probably make more sense, but it's just include, yeah.
Yeah. So, okay. Good.
Back to naming. I
Anyway,
think we're done.
yeah, it was a bag of something, some pieces of advice.
And I think we'll come back to some of the other index types at some point. By the
Oh,
way, I found it just as like an interesting tidbit. Gin and Bryn, because of their structures, doesn't actually matter about the ordering of the columns, which I found fascinating.
say it again?
Gin indexes and Bryn indexes, the order of the
Doesn't
columns
matter.
doesn't matter. Yeah.
Interesting. Okay.
I mean, mostly we're worried about B tree, so it's not too important.
Yeah, 90+%.
Yeah. All right. Nice one, Nikolai.
Thank you so much.
Catch you next week.
Bye bye.